Hello, and welcome to K305, Mechanical Basis of Human Movement. I'm John Davis. I'll be your instructor. You can just call me John. I am a researcher here at Indiana University. I'm interested in running performance, running injuries, sports injuries, as well as physical activity for health overall. Before starting my research here, I was a high school cross-country coach for a top-ranked program in Minnesota. I had a lot of fun doing that. Before that, I was a runner in college. I was a chemistry major in undergrad, actually, but found my way into studying biomechanics. And I'm pretty into running. In fact, so much I wrote a book about it right here. So I'm very interested in both the coaching side of running and in the performance side and the injury side. But my research has taken me into studying physical activity like walking, weightlifting, things like that, things that are beneficial for health, for longevity, and other sports performance things too. My research is particularly focused on wearable technology, some of the things that you might be familiar with, like GPS watches, like this. And I also do some work with some research grade stuff, like this little kind of a sensor here. Maybe someday you'll be able to clip this to your shoe or tuck it into your waistband, put it around your wrist, and we'll be able to learn more about how people move out in the real world, more than what we know right now. So enough about me. What about you and what you're going to get out of this course? So I'm hoping that in this course we'll be able to answer some fundamental questions you might have about human movement and why it's important, how it applies to things like sports, things like health, and beyond. So here's a few examples. Maybe suppose you have a kettlebell, like maybe this one. What is it about a kettlebell that makes it different than a dumbbell? So this kettlebell right here weighs 35 pounds. You could also get a 35-pound dumbbell, but I think intuitively you understand that those are a little different, despite the fact that, they weigh the same. So hopefully that's one question we'll be able to explore. Another thing maybe that you might be interested in, this has been in the news recently, suppose you're an elite marathoner, and suppose you're wearing some high-end, top-of-the-line running shoes like this. What is it about these shoes that makes people so much faster? Why can somebody expect to run 2, 3, 4% faster in a shoe like this compared to a old-fashioned shoe? Because of the format of this class, we'll also be able to do some pretty cool stuff with technology. So, for example, we'll be able to look at a lot of medical images like this one right here. Now, this is an MRI slice of the knee and lower leg. In fact, you can see the patella right here. We'll be able to answer questions like, what is it that determines the force in the cartilage, the surface of the cartilage, which is what we're looking right now. Damage to that surface is ultimately what causes arthritis and other injuries like meniscus tears. We'll also be able to look at questions like, how does the structure of a muscle and its functional role determine both things like performance and things like musculoskeletal diseases? So if we take a look at this right here, on the right we have a healthy person walking. It looks pretty normal. Those blue lines are muscles. Of course, the bones are bones. And on the left, we have data from someone with a musculoskeletal disorder called cerebral palsy. You may have heard of. It's quite a troublesome neurological musculoskeletal condition because it causes pretty severe impairment in walking and affects the ability of a lot of children to live a physically active life. So by understanding the distinctive properties of muscles, and we'll be able to look at what is it about, say, cerebral palsy that differentiates this person's movement from this person's movement. Is to some degree the way this person has to move when he or she tries to walk dictated by the properties of their muscles. As you might imagine, those kinds of questions also have important implications for sports performance too. So how this is going to work is that each week I'll post an introductory video like this that talks about what we're going to do this week, and then I'll describe the exercises you'll be doing. So every week there's going to be some videos to watch like this one, and then usually some type of assignment. This week, all you have is an introductory survey that'll help me get to know you a little bit better, and then a comprehension quiz. So that is going to be a quiz on the material that we'll cover in the week. You'll get multiple tries at it, and it's just an attempt to solidify your learning, to make sure you really grasp the material. So hopefully you've enjoyed this little preview of the course, and in the next video, we'll take a broad overview of the 4 different units of content that we'll be looking at in this course.